Welcome back, ECS subscribers. In this video, I want to go over KCNN certification. This is something I've been studying for the past, I want to say, maybe month or so. It's for work, so I need to take my exam within the next month. So I want to create a certification track and a learning path for this for the next like four weeks or month period. Just to go over some of the things I'm doing, some things I'm trying to learn with this. Take you all on my own personal learning journey, so we can all learn together for this. As always, if you like the channel, you like the content that we put out, please subscribe to the channel. There should be a link inside the right hand or left hand corner, or hit the subscribe button on YouTube. I greatly appreciate it as well for that. Let's get started. So Kubernetes is a container and orchestration platform. Also able to build containers out within your environment for application development or for security use cases. And it's through the Linux Foundation. So they're the ones that run and manage the certification tracks and certifications for Kubernetes Cloud Native program. So the one I'm taking is the most basic one. This is the associate one. And this is a link towards it. If you go to Linux Foundation, you type in KCNA, it should take you there. So the exam is around $250 for the exam take. If you want the exam plus the full subscription, it's around $500. If you want the exam plus the course, it's around $300. It's valid for 2 years. You get 12 months of eligibility to retake it, or to take it once you actually pay for it. It's multiple choice, and it takes around 90 minutes for it. Again, this is the most entry-level one for it. As you see, there are not any prerequisites to take this exam. And these are the 4 buckets they'll test you on. So Kubernetes or Kubernetes fundamentals, container orchestration, cloud native application delivery, and then cloud native architecture. And so that'll be like where namespaces, what are some core architecture components, where the API containers or API controllers or control management, what are the networking pieces towards it, what are the database pieces towards it, how the pods work, how the nodes work, what are the agents installed on it, things of that nature, how to schedule pod. So I just finished up this section for what I was studying, which I'll show you in a second. I also have the container orchestration piece as well, so networking, security, troubleshooting, storage, which I'm currently on right now. And then cloud native application delivery, which means application delivery, then debugging from that piece. And the last piece would be observability, cloud native ecosystem and principles, and then cloud native community and collaboration. So there's a couple of courses you can do for this. I get mine through my job that I can do. I believe there's also Code Cloud you can do as well, which I've heard is really good. So I might check that out as well for some practice ones. Best way is to be hands-on with this. So the more hands-on you are with this, the better off you be. I use minikube for my all-in-one environment, because I don't want to have to stand up 12 servers. I've got seems like overkill for this. So I just use minikube, which allows me to contain my environment within one server. There's other ones you can take as well. There's the Cloud Native Security Associate, which I might take next. And there's the Kubernetes Administration one as well. So I work as a security engineer. I'm not a SRE, so I don't probably need the administrator one unless I want to go down that path. I might get the security one because I'm more of a detection engineer, threat hunter work, so it just depends. And yeah, just buy it. You will enroll today, and you'll pay for it, and you pick your exam date. It's going to be done online. I don't know if this is through Pearson or through someone else. I have to double check on that as well for that too. So that's what the exam looks like. I'm not sure to sign up and some of the prerequisites for it, which are none. And that's what the core buckets are. You can use, to build out your exam guide, you can use like Cloud, or what's it called? Cloud Code. I had a brain fart, which I use as well. So I trained an agent and I just put it inside of a special project. So I scanned the entire site, all the documentation for it, and then I just started to basically tell it to prompt me on different things I should know about the exam and how to build up environments. It's up to you and how you want to do it and set it up. So that's what the exam looks like from like an exam guide. So a couple of key pieces would be, I want to cover what the architecture looks like. This was going to cover, let me go back. This diagram, if you understand everything within the diagram, this will cover on honestly half of the exam, for what I've been told. This covers all of this. They're going to quiz you and test you on that. So let me walk you through this. So again, I'm using minikube. So minikube is, think of it as a Kubernetes piece of, or yeah, think of it like a container software or container architecture you're able to use to build out a Kubernetes environment all within one server. So instead of having to build multiple different servers to have all of these components, it's all within one server. So this is very good for a test environment, dev environment, and just to experiment with. You would not do this type of production environment, obviously, but for the exam, this is more than enough for that. So that's why I did it, because it's just easier. So a couple of things for this. I'm gonna go up and down right now. Let me see. All right, cool. Should work. So technically speaking, this is all within the cluster, but I just set up this way because it looks better from an aesthetic standpoint. So minikube cluster contains a kube node, right? That's all within one environment. So I'll go through one by one. Kube control plane is the interface that helps to control all the components within your clustered environment. Kube control plane has all these control plane components. You have the API server minikube, which is the interface or application program interface. This is what talks towards the rest of your components. You have the etcd cluster, or this is your cluster database if you're doing any web app development work, for example. This stores the state of it. You have the kube control manager. This controls the environment, which is part of the control plane. And you have the kube scheduler, which schedules your pods. And pods within Kubernetes are just containers. And a container is, think of like almost like a lightweight version of a virtual machine, but has everything encapsulated inside of it. So networking aspect, networking, storage space is all contained inside one environment. So it's a much more lightweight version of it, which makes it more efficient. Probably not the best explanation, I'm still learning this myself, but toward my understanding. It all runs on Docker, which is the minikube driver. So the Docker does all the backend work, functionally speaking. You have the kube node, and nodes are, if you're familiar with like any Splunk or SIM technology, nodes are just computers or servers. So it could be a virtual machine, could be an on-prem server, but a node is just one computer or one machine. Then you have the kubectl agent, which is installed on your actual hypervisor or whatever machine you're using. This interfaces with the API. So this is how you run your commands against the API interface. Kubelet agent, or kubelet agent, kubelet, if I pronounce that correctly, is the agent that's installed on your pod to talk towards the rest of the components. And you have kubeproxy, which is handles the networking settings for your machine or your pod. So these are all the main pieces of it. I don't think they'll test you on the minikube, because it's just a external piece of software from that standpoint. But they'll test you on all these other components though. So again, you have control plane. So everything here is under the control plane. So API server minikube, etcd cluster database, a kube controller manager, which controls the environment, kube scheduler, which does the pod scheduler, or the pod scheduling, so scheduling out your actual deployment of your pods, containers. Then you have the kube node. Kube node is going to have your kubelet agent on it, or kubelet. Drop in the comments if I'm not pronouncing that correctly, or if I'm mispronouncing that. My apologies. I could be wrong. I don't know. You also have the kube pod, which is the actual container, which hosts your applications. I'm running MongoDB and web application for that from a database. You have kubeproxy, which hosts your networking settings as well. And then Docker runs underneath the minikube, which Docker runs underneath minikube as a driver. Encapsulate all of this. Then you also will have like namespaces. Namespaces are, let me see if I can do this. Please work. It's in a way. The namespaces is, how do they put it? Not segmentation, or technically segmentation, or partitioning of your device. So you can have, there's a couple namespaces by default. There's what is it? Fault namespace. It's a fault namespace. There's a queue namespace. And you can have the production namespace. This is how Kubernetes partitions its clusters. So default namespace is if you don't specify what pod you want to put this in, or if you don't want to specify the specific pod you're trying to create for the namespace to put this in default. You have kube settings, which I think is applied across the board no matter what namespace you're in. Some of these are local, and some of these are system-wide for namespaces. But this allows you to run an entire app within a namespace, and the settings don't affect the other namespaces unless it's system-wide namespace. So you could have for example, you could have a Splunk ES pod attached to a production namespace, and you could have a web application pod attached towards the production namespace, and then you can also have a default. You can have a CrowdStrike or a Falcon XDR pod attached towards the default one, and these two will have separate settings, and the two will not touch each other. They're completely partitioned away. That's namespaces in a nutshell. Again, I'm still learning this myself, so if I'm wrong, please do let me know in the comments. This is why we study, and this is why we practice and build. Let me pause on that. That's a quick architecture overview of it. I actually have an environment up and running, so I'm going to show you that as well. So I'm running Ubuntu server, or Ubuntu desktop, technically speaking, on a VMware. Has it disconnected? That's my bad. But yeah, I'm running Ubuntu desktop on a VMware hypervisor. What version is this? Yeah, VMware hypervisor. So let me show you. Looks like, so this is minikube I'm going to be going to. This is my K demos folder. This is where all of my YAML configurations are. And Kubernetes for the scripts and template to run on YAML. You can do syntax through either Cloud, or you can just pull the templates out from the direct site for Kubernetes. They'll have examples that you can pull from, or GitHub. It's up to you. So I document all my processes. So, step-by-step instructions I have to run this environment. The documentation is especially important if you want to work in industry. So you can check the status of your minikube to see if it's up and running or not. So these are some of the architecture components we were talking about. Control plane is down. The host is stopped. Kubelet agent has stopped. API server interface is stopped. And then kube configuration files are stopped as well. So we're going to want to start this up. So we're going to do minikube start driver equal Docker. Docker runs on the back end. Put powers this. Should take us a 60 seconds to get up and running. Check status again. Awesome. So control plane. So the host is running. Kubelet agent is running. API server is up and running. And then kube configurations are configured. Or they're back up and running. Let's check to see what nodes I have now. Post CTI. So the fall has been up for 15 days. Kube node lease has been up for 15 days. Kube public has been up for 15 days. And Kube system has been up for 15 days. Let's see what our nodes look like. These are all my nodes. So these are all my these are all my nodes. These are all of my machines. I don't have individual pods inside each one of these. And if you want to see what each pod looks like, we'll do kube system first. These are all the pods or apps within my system node. So I have database 1, API server for minikube, kube controller, the proxy one, networking, scheduler, and storage provisioner. They're all up and running. I don't think I have my cron one. Should be gone now. Be gone. Let me do. This is YAML. YAML is indentation specific. So if the indentation's not correct, it won't work. So I have one whole database and a web application up and running. So my web app YAML. Also create some cron job, which I've already deleted. I don't want to run every 5 seconds or 5 minutes. So a job is just a one-off time command or like setup. A cron job for like basics runs on a schedule. If you've ever used Splunk to do any alerting functionality or detection engineering, you'll know what cron jobs are. So this is my API version. API versions for cron jobs are different than the API version for my YAML or my Mongo ones. Kinds of cron job. The name of it is my cron job scheduler. This runs every hour? No, it runs every minute. Runs every minute. Job template, spec, template, container. Container name is my job, cron job. Image is busybox, so it's a separate pod. Command is echo, schedule job running. Restart policy, never. So this won't restart with the machine. But that's what I've been working on so far. For my exam, I still have a long way to go. I have like 3 more of those modules. So if you go back, I've covered most of this. I need to start going over the container orchestration piece from it. That's what I'll be doing this week. And next week, I'll be doing cloud native application delivery. And after that, I'll be doing some cloud native architecture. And after that, some practice exams. So that's it in the nutshell of what I've been studying so far. I'm still on Kubernetes fundamentals, just finished that. I moved on to container orchestration, so I'm really excited about that to learn. Please let me know how you guys enjoy this video, if you like this type of content. If you do, please again subscribe towards us by clicking on the big subscribe button to the YouTube algorithm. That really helps me promote the channel, get more members as well. And then if you're a CyberRange member and if you want to see something just within the CyberRange, so if you own a CyberRange that helps you get hands-on experience for cybersecurity topics within a production environment, so just let me know that as well. We're always happy to help you guys out. Otherwise, if there's no other questions, just jump into the comment section